All right, so now we're verifying solutions to differential equations that have a second derivative in it. So if we look at a problem like this, verify that y equals x to the 4 on 2 plus ax plus b is a solution to the differential equation d squared y dx squared equals 6x squared. And hence find a particular solution given that y of 0 equals 2 and y of 1 equals 2. All right, it's very similar to what we did in the previous video, so go back and watch that if you haven't already. And basically, we just got to do the process twice now. There's actually two ways you could answer this problem. The first is to say that you've got the original function here, y equals x to the 4 on 2 plus ax plus b. If we took the derivative of that, we would get some answer. And then we take the derivative again, the answer should be 6x squared, because this just says that the second derivative of y with respect to x is 6x squared. But that's actually not how I've done it in this video. What I've done is I've sort of started here and I've taken the integral of 6x squared twice. And hopefully you'll see that the answer is this. So let's step that through. We're starting with this. The second derivative is 6x squared. All right, take the integral of both sides. So undo the differentiation. So you're going to get the integral of 6x squared dx on the right-hand side. And on the left-hand side, we just get dy dx, which is the first derivative. All right, hopefully you know your integral rules. If you take the integral of 6x squared, you raise the power by 1, and then you do 1 over the power raised by 1 comes down the front as a coefficient. In this case, it's multiplied by 6, so it's 6 over 3, which is going to give us 2x cubed plus a, and I've called this constant of integration capital A, and you'll see why in a moment. All right, the next thing we're going to do is we're going to take the integral again. So we're taking the integral of dy dx, and we're going to take the integral of this. So we're just taking the integral a second time. And again, applying our integral rules, our power rule for integration is going to get x to the 4 on 2 plus, all right, ax. When you integrate a constant, you get an x multiplied there. And then we're also going to get this other constant of integration b. And so that's it. We've pretty much shown that this is a solution to this equation. So we can just sort of summarize that and say that, all right, therefore y equals x to the 4 on 2 plus ax plus b is a solution to this differential equation. All right, the last thing we need to do is find a particular solution. So given that when x is 0, y is 2, and that when x is 1, y is 2, we can do the following. We're going to take this, and we're going to sub in when x is 0, y is 2. So the left-hand side equals 2. Sub in zeros wherever there's an x, and you'll see that b equals 2. Similarly, over for this initial condition, we call them initial conditions, we're going to sub in when y is 2, x is 1. So we sub in a 1 here. Okay. Subtract 2 from both sides. Subtract 1/2 from both sides. Hopefully you can see that you'll get negative 1/2 as your solution for A. So therefore, our particular solution, just subbing in A and B now into this. So we get y equals x to the 4 on 2 minus 1/2 x, because that's A and B is 2. So that's our particular solution to this differential equation, given that it goes through these 2 points. So let's look at that visually, because I think a visual diagram can be explanatory. So this is our particular solution. Now we said, well, one thing we can firstly check is that it goes through the points that the initial condition said they would. So it goes through the point 0, 1, and that's not right. It goes through the point 0, 2. Let me fix that. Goes through 0, 2, which we said it would go through. And it also goes through 1, 2, which was also one of our conditions. So this is looking good as our particular solution. What we can do next is we'll take the derivative of that. That would give us the first derivative. Maybe not super important for this problem because we're more interested in the second derivative. But the first derivative of this is this, 2x cubed minus 1/2. And then if we take the second derivative, we get 6x squared. So this is our particular solution to the ordinary differential equation, this. given that it goes to the point 0, 2, and 1, 2. All right, hopefully that clarifies that. I'm just going to pose a problem, so just give me 1 second. All right, so here's the problem. Verify that y equals ae to the negative 2x plus be to the negative 2x is a solution to the differential equation d squared y dx squared equals 4y. Hence, find the particular solution given that y equals 0. Sorry, y of 0 equals 3 and y of log e of 2 equals 9. So give it a go. Let me know what you think. Also, if you're finding the videos useful, feel free to subscribe. It makes me feel like I'm not talking to a screen all day. And yeah, hopefully you're finding some of this stuff useful. And good luck with all your studies.